Today is October. It's October. We made it. I no longer have to play the Green Day song, Wake Me Up When September Ends, every day when I get out of bed, so that's good. Nothing. I actually really like September, but I especially like October.
Why do you hate September?
I like it. May 26th.
So when I first met most of you guys, whatever that was, 5 weeks ago or something, 6 weeks ago, we started a lecture just like this, except it said solving linear equations, and then began our super long journey of how to add things to both sides, when to multiply by a fraction, when to divide, how to cancel things out, when to move the x's this way. And that's always the way my algebra goes. It takes a month or a month and a half to get through the basics of just how to do basic algebra. And I would say that almost all of us have just really gotten to where I want us to be. So this is not going to be a difficult lesson for you at all, just because of how well you've done on all the other stuff. So I just quick want to talk about the difference between equations and inequalities so that you conceptually understand why we're going to do what we're going to do. So this is not an inequality. I just would like to be clear. This is the simplest equation I could possibly give you. So let's say I gave you this equation. Like this would have been day one, right? And everyone knows what the answer is because either we do it in our heads or we mechanically attack it by subtracting 4 from each side. And when we're done and we take away 4, we all agree that x has to equal the number 6, right? Yeah. So what we don't talk a lot about, like maybe I should do a better job of it, is the fact that when you solve an equation, you're finding listen carefully now for about a minute, you're finding the one number that makes that problem true, right? There are no other numbers in the known universe that you could put in place of x up on the TV and say that that number plus 4 equals 10, right? 6 is the only number that when increased by 4 equals 10. We agree. Mm-hmm. Good. So that's what we've been doing for 6 weeks, 5 or 6. I've lost track, but I think it's 6. And what we're going to do today is we're going to change it up. And instead of saying, I want to know what number makes a problem true, we're going to find an infinitely large set of numbers that all make the problem true. So I want you to understand kind of background-wise what I'm talking about. Imagine the problem like this. By the way, I'm not going to play the song and dance game with you of trying to come up with cute little reasons to memorize which symbol is which. You're in high school now. So we're going to memorize that sign is called is greater than. Got it? If it points the other way, it's an is less than. Remember, if we put a little line underneath it, what does that mean? Or equal to, right? So by putting a little line underneath it, you just increase the number of possibilities. You basically say, not only does the left side have to be greater than the right side, but it could equal the right side as well. So we'll talk about that. And if you have to come up with some stupid little thing about, like some people say, ooh, look, L stands for less than. And if this arm gets tired and falls over, it's this. And I'm like, ain't nobody got time for that. I mean, give me a break. So you should just memorize the symbols. If you can memorize lots of things in your life, like door codes and phone numbers and locker combinations and stuff like that, you can certainly memorize your symbols. So let's get them on paper just once, and then we'll hopefully never have to talk about this again. So this symbol is greater than. Okay. This symbol is less than. And then, of course, if I add, like I said, the little line underneath, if I put this symbol and then put the extra stipulation on the bottom like that, now I'm saying that what's on the left can be greater than or equal to. So we say is greater than or equal to. It's not that I don't have compassion for you as you're learning, but a day from now, I don't still want to be talking about which is which with you, right? We got bigger fish to fry than that. And then the last symbol that we'll ever see for inequalities is this one. And that is is less than or equal to. So put that down in paper, and I hope I never have to put those up there again. So that's like your little reference area, which you hopefully don't need for more than like just a few minutes today. Good. All right, so having said that, let's get back up to the purple problem up at the top right corner there, and we're going to attack this just like we would attack an equation. And so mechanically, we know how to do this. Our objective is to still get x by itself, and to get x by itself, what are we going to do? We're going to subtract 4. So I'm going to show just a little bit of work today. But again, I'm kind of past the point with you where I need you showing that. I didn't even really look that close on the quiz at every little step. Like, are they showing me that they're doing times? Are they showing? I'm kind of past that. You've probably figured that out. So I'm going to cancel out these 4s, and I'm going to be left with this statement right here. And how do we read that answer? Right. And so I want you to see now the distinction. The red problem on the left, we found the one number in the world that when you add 4 to it will equal exactly 10. What we're looking for now is to say, I just need all the numbers that when I add 4 to them will be bigger than 10. And we have found what's called not a solution, but a solution set. So that's the set of answers. Again, it's not an answer. It's not one number. We're saying x can literally be anything greater than 6. So give me one possible solution to this problem. 7. Could I use 6.2? 6.2, 127,000? How about 4 million? So this is an algebraic solution set. This is how we say, using symbols, what all of the answers to this problem are. X can be anyone bigger than 6. The second expectation for the day is that you understand now how to graph these solutions on a number line. So having said that, and Delta Math has a number line built into it, right? But when you do like a quiz for me or a worksheet or something, you'll sketch a little number line. And I know that in past years, you might have had, your teachers might have asked you to put a whole bunch of numbers on the number line. I don't know if you remember that or not. For me, you don't need to. The only numbers I ever want to see on the number line are the numbers that I care about. And the only number that I care about in this problem is 6. And so to mark it on my number line, I put a little tick, and then I write underneath it, I label what that point is on my number line. You don't have to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not interested. You can if that's your thing, but you don't need to. Now, what I need to show someone, first off, let me ask you this. Is 6 a solution to this problem? No. It is not. If I put 6 in here, it's not going to work. If I put like 6 plus 4 is greater than 10, that of course is not true because 10 is not bigger than himself. So I need to have a way to show someone on my graph that 6 doesn't, that it doesn't work. How do you do that? Do you know? I circle it and I do not color it in. By not coloring in the circle, I show someone, anyone who knows anything about algebra would look now at my graph and say, oh, they're trying to tell me that something exciting starts happening at 6, but 6 does not work. I will. And so we call this shading the number line. And so what you want to do is fatten up your number line like this. And basically you're shading a solution region. And then you want to give it a nice big fat arrowhead like that. And that's how you show someone that x can be anyone bigger than 6. We don't usually graph solutions to equations because it's like, well, what's the point, right? It's just it's a number. Like, but with this, we want to graph because it's an entire infinitely large set of numbers. And we're showing people that anyone to the east of 6, anyone over there, solution. Okay. So this purple thing up here is the algebraic solution. And this white thing down here is the graph solution. Do you understand that? Okay, so now what I'm going to do is I'm going to run through a bunch of examples with you, and I'm hoping that I can cover all of the topics that I want to cover with you in these examples. You will not see any problems today with fractions. Those will come on a Wednesday. Unless you're just kicking booty and you want to do them tomorrow, we can. But you will get answers today that have fractions, but the problem itself will not involve any fraction killing, just for the record. All right, so let's get to it. So these are our official examples now. So we have -9 plus 4x is greater than 23. And again, we're not looking for the number, we're looking for the set of numbers. And to find that set, you have to find the boundary point, kind of what we're used to finding as our solution. What would we do first? We would. And so I'm going to drop down my 4x, I'm going to drop down my inequality sign. And what is 23 plus 9? 32. And what would we do last? And we would get x is not 8. X is greater than 8. Very good. So that is my algebraic solution. And again, if we had to graph it, you just make a little sketch of a number line. We only put the number, later on there will be numbers when we graph compound inequalities, but for now, just one boundary point. So I label it 8. Is my circle open or closed? It stays open because 8 doesn't work, and then I'm going to graph everyone to the right of 8 because that's what my solution says. Any questions on that? Okay, next one. Let's do 7x minus 6 is less than or equal to 22. What do we do first? Add 6 to both sides, and we drop the 7x, and we drop the is less than or equal to. And what is 22 plus 6? 28. What's our last step? Divide by 7, and we get x is less than or equal to 4. So this time on the number line, again, please don't put a bunch of extra fluff on there. Don't waste your time with it. I'm just going to label the boundary point. The boundary point is where the solutions and the non-solutions get separated. So I'm going to circle that. Don't draw your circles up above or anything. Some people do that. It's a little creepy. Just stick it right on the number line. Is it open or closed? Good job. This time we're going to close it because we're trying to tell someone now, if Mr. Manlove were to walk in and look at this, he'd say, oh, you're telling me that 4 is a solution. And it is a solution because the left side doesn't just have to be less than the right side. It can be equal to the right side. And that's why 4 also works. And which way will I shade? To the left. Any questions so far? Okay, this next problem, there's a lot of meat on the bone, so be careful. So let's do -10 is greater than 3x plus 5. You're going to want to probably, when you get done with this example, highlight it or circle it or do something to draw your attention to it, because there's a little thing that happens at the end that is a pretty common source of lost points. So, ready? What do we do first? Yeah, let's take away 5 on both sides. And so we bring everything down just as is. And what is -10 minus 5? Definitely -15. And then the last step is to divide by 3, and we bring down the x and we bring down the inequality sign. And what's -15 divided by 3? Okay. Can someone read me that answer? Okay. So here I go. I'm going to make a number line. I'm going to place my boundary point. Circle, open or closed. Keep it open this time because there is no or equal to. So by leaving it open, we're saying -5 doesn't count, but it's where all the action starts taking place. And which way should I shade, to the right or to the left? This is why I did this example. So I hope you're still with me, listening. Can you read me that symbol out loud? It is. It's an is greater than. So I'm going to shade to the left. And you might say to yourself, Mr. Ahern, are you okay? That's a greater than sign. Why did you shade backwards? Does anyone know why? I haven't heard. I'm going to give you guys a tip. I'm going to tell you right now that, again, some of you are just wired to, like, when I say you should do it this way, you just are wired to go, I'm going to do it my own way, which is weird. I hope you guys can take this advice. This answer, while correct, is really terrible. And the reason is because it makes us have discussions and conversations about which way is actually the logical way to shade. Those of you that are really thinking about the problem understand that the way that I shaded is correct. But some of you might be fixated on the fact that, hold on, that says greater than should go to the right. So the way to solve this once and for all is to always make sure with inequalities that your variable goes on the left. With equations, we've had this talk, and I've always told you, I don't care. 5 equals x, negative 10 equals x. Who cares? It doesn't matter. With inequalities, it matters unless you know what you're doing. So I'm going to take this answer, and I'm not going to read it that way. I'm always going to think of it from the direction of the variable. And what the answer actually should say is x is less than negative 5. That's a very important 30 seconds of this lesson. You may take it or leave it. But as the guy who has sat over here on this side of the desk for 28 years, I'm telling you, you should take that advice. Put your variable on the left, even if it's the last thing you do. You've already done the problem. Right before you put a box around it, move that variable, switch your point of reference. It's kind of like me saying, Dallin is taller than Landon, right? But if I reverse that statement, I have to reverse the comparative thing in the middle. So if I said it backwards, I wouldn't still say is taller. I would say Landon is shorter than Dallin, you see. That way there, when I see it that way in the purple box, I'm like, oh, X is less than. Well, of course, you're going to shade to the left. It's a no-brainer. So, muy importante. All right, let's go again. Negative 2x minus 76 is greater than negative 66. ¿Qué tenemos que hacer primero? What do we do? We add 76 to both sides. Very good. Oh, here, I'll show a little bit of work since sometimes I don't. There you go. We'll stick a nice, cute plus 76 under both sides, just like that. Going old school, early September work amount right there. I'm going to cancel out those 76s. I'm going to drop down the negative 2x. I'm going to drop down my comparative symbol. And what is, oh, good God, what is negative 66 plus 76?
10.
Definitely positive 10. What's my next step? I'm not done. Divide by. There are no 2's. Oh, negative. Oh, negative 2. Wonderful. And so I'm going to get what for my final answer? Exactly. Perfect. How did I do? What did I do? You think I did something wrong? What? Why would I do that? No, the X was already on the left. This has nothing to do with anyone being easier to understand. I did not mess up. I always do that on purpose because I want you to think that I did. There's something more to be gained in your learning when we talk about it like this. So this is something you need to add to your notes and add it now. It's because we divided by a negative. So I'm going to put a little arrow right there, and you can add this to your notes. When you divide or multiply by a negative, comma, you must switch. Jeez Louise, excuse me. Speaking of switching, I switched my C and my H. So, that was weird, right? You must switch the inequality sign. That's going to start happening to you now on a lot of problems. And the reason for that, if you think about it, is when I divided by a negative, I changed the sign of the left side and I changed the sign of the right side. So it seems fair then that the sign in the middle would have to follow along to the right. So what I did there was not a mistake. It was very much on purpose. I divided by a -2, so I had to switch the greater than to become a less than. Everybody get that added into their notes? All right. Then let's just quick make a sketch. By the way, in Delta Math, you only have to graph on the number line on roughly half of the problems. So half will have a graph and ask you to graph it, and half will just ask you for the answer. So you'll see. So I'm going to stick my boundary in the middle. -5 is my boundary. Is he going to be open or closed? He's going to stay open because -5 does not count. You got to show that. And which way will I shade? To the left, because it says X is anyone less than -5. And the less than -5s are the guys to the left. And if you always keep your variable on the left, you'll never have stress when it comes to graphing. Good. All right, let's go again. I'm going to try to trick you with this one, so you've been warned. 48 is greater than or equal to 86 minus 4x. What should we do first? Yes. So I'm going to again show a little bit of work so that no one has to sit there and go, gosh, I wish he'd tell me how he got that. So I'm going to get rid of the 86s. And before I worry about the math problem on the left side, I'm going to do what I've always said I should do. And that is bring down all the stuff. So I'm going to copy down my -4x. I'm going to copy down my inequality symbol. And now, either through the use of a calculator or that powerful supercomputer locked in your skull, what is 48 minus 86? It's negative. Let me get that out of the way first. Like if you didn't put negative, I would probably have some funny things to say. -38. Very good. And again, just feel free to use a calculator for stuff like that. It's okay, really, it is. And then what's the last thing we do? Let's divide by -4. Cancel those out. And again, before I worry about the math problem, if I'm any good at this job, I've gotten this point across to you. Don't worry about the math problem. Worry about all the other stuff first. So drop down your X, mission accomplished. Should I drop down my inequality symbol? Like this? Is that okay? No, why not? Because I divided by negative. Good job, Addie. I divided by a negative, so I got to switch the sign. That's the law of the land. And can I divide 38 by 4? No, 38 gets skipped over. 4 times 9 is 36, and 4 times 10 is 40. So I know I'm working with a fraction. I know it will be positive, and I'm going to put it as a 19/2. So what do you think of my answer? Yeah, you should hate my answer. So let's write, you should. Let's write it backwards. What would it say if we wrote it the proper way? X is larger than or equal to 19/2. And now I like this because now when I go to graph it, the inequality sign and my brain, they're going to match up and everything's going to just seem sensible. So I'm going to put my boundary point, which again, you can just mark it. You don't have to figure out that it's between like 9 and 10 and get all perfect. Just mark it. Open or closed circle. Closed, and which way will we shade? To the right, because it says X has to be greater than or equal to 19/2. So I make my decisions based on the properly ordered. So, still good? Okay, let's go again. You know what? We're probably just going to start on it tomorrow. This is taking a little longer than I thought it would. And so don't worry about the Delta Math assignment. You're going to see that it assigned itself, but it doesn't matter. Just hold off. Let's get through some more notes. And then tomorrow I'll give you a nice big chunky fat work day and you can just knock it out in class. Okay. So hang with me here. Yeah. Don't even worry about starting it today. So now I'm going to start throwing more difficult inequalities at you. You remember the day we did this like 3 or 4 weeks ago where it's like, oh, now there's variables on both sides. We're not scared. What should we do first? Right. You have learned well, right? I'm going to subtract 2x from both sides. And I'm doing that because it's smaller. And today you hopefully get to see the benefit of working with the smaller one is because now I do actually care about not having to divide by a negative. I can avoid that if I want to, which is pretty cool, right? So now I'm going to drop down my -2. I'm going to drop down my inequality sign. What's 10x minus 2x? Mm-hmm. Next step, add 1 to both sides. And I'm going to bring down my 8x, and I'm going to bring down my inequality symbol. And what is -2 plus 1? -2 plus 1, -1. Next step. Should I switch my sign? Why not? That 1 is negative. Very good, Kason. So don't, I know I was going to make fun of, no, we don't switch the sign. I get this question a lot about, hey, should I switch the sign because that 1 is negative? That 1 is not what we're dividing by. So we're just going to bring down the x, we're going to bring down the sign, and we're going to understand, of course, that 1 cannot sensibly be divided by 8, right? So we leave it as a fraction. What do you think of my answer? We hate it. Why? It's not wrong. It's just, it causes people to graph hilariously. Delta will not like it either. Right. And so, yes. So let's just, as a class, let's agree. We're going to stick our variable on the left. That's kind of one of our new battle cries here. What's it going to say, Brendel? If I flip it, what will it say? Nice job, buddy. So let's not graph anymore so I can get through these last examples. Are you guys cool with that? You'd have no troubles. Open circle, graph to the right. Escape. Okay. Next one. And after this, there are 2 more. Okay, guys, just for your mental preparation. What do we do first? I'm going to add 4x to both sides just because -4 is the smaller one. And by moving him, then I won't have to deal with the dividing by a negative. I can control that, Braxton, which is really nice. And so the -4 is the smaller one. So I'm going to add 4x's to both sides like this. I'm going to cancel these ones out, and now I'm just going to bring a bunch of stuff down. So the sign stays the same. The 6 is the sole survivor on the right side. What's my left side going to say? What's all of this going to say in this white box? Change that for me. It's not -2. What is -2x plus 4x? So I have 2x minus. Next step. Add 3 to both sides, and I get 2x is more than 6 plus 3. Next step. Divide by 2, because the 2 now has to get detached off of the x, and I get x is greater than 9/2. And again, graphing, open circle, shade to the right. So I got 2 more, and then I want to show you what the delta is going to look like, just because there's the math is one thing, but then knowing how to do the circles and the lines and stuff they'll take just a moment. You guys still feeling good? All right, so this is what we've worked towards now for this whole lesson, is to get to this point where we can now solve a problem like this. So we have -5 minus 4 times the quantity of -6x plus 1 closed quantity is greater than negative 7x minus 4 minus x. This is looking now more like, yeah, a little more upper level now, right? And so again, we're not going to, why take 5 days to learn this when you already have all of the mechanical know-how? You know the steps. There's no fractions to kill. So what do we do first? We distribute. So we're fixated on this left side and this right side. Like we understand still the same laws apply. I'm going to simplify, and then I'll do the whole algebra thing. So on the left side, I'm going to get negative 5. And then what? Distribute negative 4, giving me what? Plus 24x. That's right here, red arrow. Next red arrow. What's that? Minus 4. Good. And then I'm going to copy down my sign, and I'm going to get to work on the purple side. What is the purple side going to be? Negative 8x minus 4. Good. So we're still not to the point where we can start thinking or should start thinking about adding something to both sides. I'm still looking at the red side. So I'm looking at you, buddy, right here. And you're still not how I want you to be. So what do we do? You combine like terms. Some of you are struggle with those words. Just put them together, dudes, just like they are. Just take those two green circles and put them together, and we're left with 24x minus 9. So just like before, there's work to do before we actually start the problem. That was all just prep work, right? Now, who should we move? Definitely move the negative 8x. So we're going to add 8x to both sides, and that's going to give me 32x minus 9 is greater than negative 4. Everyone see? Added 8x, added 8x, like that. What's the next step? Add 9. Negative 4 plus 9 is? Definitely positive 5. Last step. Giving me an answer of x is greater than a fraction 5/32, like that. Okay. How'd that feel? Good? All right, last example, and then we're going to hop over and take a look at what the delta is going to look like. I see some of you still head up, head down, looking at the TV. How close are you to, can I move it this far and have you all be okay? Okay, last example, guys. Yay! So let's do 7 minus the quantity of x minus 5 is less than negative 10x minus 7 minus 4x. What do we do first? Distribute that dang negative, right? Good job. And so when I do that, my problem isn't going to look different. It's going to say 7 and then what? Careful, I need more. 7 minus x and then plus 5. Let's head over to the right side. What kind of work can we do over there? Add those like terms. How many x's? Good job, negative 14. Thanks for saying negative that time, buddy. All right. And let's clean up that right side. This feels kind of like the last problem, right? Let's clean up that left side and make it acceptable. And the like terms are, I hope it's obvious to you, right here and right here. So we're going to put those together to get 12. Then we copy down the rest. And as always, we're back to that spot where you have a decision to make. What should I move? Yeah, let's add that 14x to both sides. How many x's is that going to give us on the left? Good job. So we're going to have 13 x's over here. And I'm going to do two steps at once. And if this makes you angry, you're welcome to vent a little bit. So I moved my X's over to the west, which means then that who has to move back to the east? The 12 does, which is going to give me, good job, negative 19. Everyone comfortable with that? You can do that too if you want to. Just don't mess it up. I mean, I'll mess it up from time to time. We're human, but try not to mess it up. How's that? And then when we get here, what do? Divide by 13, and we're home free from there. So we get X is less than negative 19/13. So I'm going to keep the recording going, and I'm going to switch over as soon as you tell me you're done copying this down, and I'm going to show you how it works in Delta Math, okay? We good? All right. So heading over to this, there's going to be 4 types of problems. There's going to be simple ones like this. And I'll zoom in. That could be enough zoom. You guys have good young eyes. What would I do first on this problem? I would add 4 to both sides, which would give me 8x is greater than or equal to what? Good job. I love the good math when we don't have to slow down for that garbage. And then what's the last step? Divide by 8, which gives me x is greater than or equal to negative 8. So when I go to type it in to my box, I type it in as x, and then I can choose from one of these symbols, x is greater than or equal to negative 8. Now, obviously, this is a problem that wants the graph. And so x is greater than or equal to negative 8. So what I'm going to do is I'm going to go to negative 8, and I'm going to get a... Oh, I wonder if it wants me to submit that first. Oh, yeah. So I'm going to go to negative 8, and I'm going to make a line like this. And if I click, and if I stopped... By the way, if you want it to go away, just double click the line. So I'm going to click on 8, negative 8, and I'm going to drag it. Notice if I stop dragging it, it doesn't give me an arrow. So I need to drag it all the way out to get the arrowhead. And if you want to change the circle, check this out. You just click on it and it goes from open and closed. Got it? And then that's that. And so I'm going to, again, click, drag. Do I like this graph the way it is? Yeah. I do. I like the closed circle. I like the directionality of it. So let's take a look. You're also going to see problems like this. Oops, that's a terrible example. Let's see if we can find something more exciting than that. Yeah, this is better. Let's do this one. What would I do first on this problem? Good job, you guys. Let's subtract that 41 from both sides. So I'm going to drop down my negative 6x. I'm going to keep it still is greater than, what's 17 minus 41? Nice. Last step. So what's my answer going to be? X is less than positive 4. So that's a real hotbed for mistakes right there. I had to remember that when I divide by a negative number, I switch the Pac-Man backwards, right? And then, of course, I know that a negative divided by a negative is a positive. So on this one, again, I'm just going to type it in. X is less than 4. And then I'm going to go down to the number line, make sure I go to positive 4, and I'm going to drag to the left. Do you like my graph? No. It's got to be an open circle. So you just click it, and that changes it for you, right? And then the only other levels are just, so you'll notice in these, I know you're wanting to pack up and stuff, but it's really hard for me to keep working when you're doing that. So could you stop? I'm sorry, I know it probably doesn't make sense to you that I should care about this, but it's so bad. So let's do one of these, and then I think we'll call it a day after this. So notice this time there is no graph, right? Notice also that it does not want your variable on the other side. Like Mr. Roscoe said, it's not going to allow you to do it backwards. So what do we do first in this one? So we get negative b, and then what? Plus 4b. Nice job. You guys are still doing that thing where you're packing up, and do I need to pause the video so I can scold you? Hang on a second. What's the next thing we do? Combine like terms on the left side. How many b's are we going to get? Good job. So we have 3 b's minus 8 is greater than 5b's minus 11. Which b should we move? Yeah, let's subtract the 3 for both sides. That's going to keep us positive. So I'm going to be left with -8 is greater than what? 2b minus 11. Next step. We're going to add 11 to both sides. So we're going to keep everything the same. What's -8 plus 11? It is not -3. It is 3. Last step, which is going to give us this answer. And it is not what we want, right? You guys picked up on this really quick. What's wrong with that answer? It's backwards, right? So we want to flip it to say b is less than. So notice I don't have to type in the b this time. I can just choose from this drop-down menu like this, and I want the is less than, and then I just, for a fraction, I just use the slash on my keyboard, and that's it. You don't have to graph on this. So, everybody good? Okay, thank you.